Welcome to this third recorded video inside of the 01 Jupyter Lecture Notebook. This video will cover the part of the notebook that discusses kernels and cell execution. The video will be here for you to watch. This is replacing the old video from the previous time I taught the course. So far, we've mostly just seen text in Jupyter Notebooks in Markdown cells, much like this one here, which is again a Markdown cell. We've seen a little bit of code, but not much. Now, the whole point really is to integrate explanatory text with code that actually does something. So let's talk a bit about how that is going to work, and we'll get into more detail later, starting with the second module in this course. So the first thing to understand is that a Jupyter Notebook environment supports the use of many different kernels. What is a kernel? A kernel is a programming language. Different kernels have different syntaxes for input, meaning what you type into the kernel for it to execute. And the output, what comes back from the kernel after the execution of the code. And they often are useful for very different purposes. So what you'll see here is that the kernel we have is Python 3. And you can switch this kernel and you can click here to try to do it. And it will say which kernels are available for you to try to switch, along with anything else that you have for open notebooks. I have another notebook open. You have Julia R available to you. I set it up in the environment on the hub, just for those that are learning other languages and maybe want to try things we're doing in those other languages, or if they're more familiar with those other languages, just to try some things. But we will do everything exclusively on Python 3 in this course. So Python 3 is our cup of tea. The communication between the user and the kernel is broken down into these cells that we see. There's the Markdown cells, and then there's the code cell. When you edit a code cell, you hit Shift-Enter to execute the contents of the cell and move on to the next cell, or Control-Enter to execute the contents and stay in the same cell. I've talked about this before, primarily in the context of Markdown cells, but I did some with the code cell in one of the first videos for this notebook. So here I show you that if I pressed, I'm going to do Control-Enter, that there's this input. This is the 11th cell I've run in the time I've had this notebook open. And there's the output associated with it. So you want to keep track of that input and output. And if I run it again, the number switches to 12. So all that number is going to tell you is at what point was that run in the notebook, and then any outputs that are given to it. And if you suppress the output with like a semicolon, as I say in the code comment, again, there's that hash, and then I do Shift-Enter or Control-Enter, either one. See, I'm running it over and over again. There's no output, so that suppresses the output. So now I've run it quite a few times. So you can have multiple lines of code within a single code cell. Blank lines and comments help enhance the readability of code, and readability of code is very important. And I ask you, and I mentioned this before, to add lots of code comments throughout this course. In a lot of the notebooks, I'll provide a lot of code already written for you and ask you to comment it, because that's going to force you to understand what each line of code is doing. So here is another activity, and again, I'll walk through this activity within this video here. You might want to just try to pause the video and do this activity for yourself, and then watch the video from this point on to see if what you did followed what I was asking you to do. So make sure that you're understanding the instructions I write in the way I'm intending them to be understood. So there's three parts to this activity. I first want you to add a blank line to separate the two lines of code. And again, if you want to pause and do it, do that now. Okay, I'm going to go on and I'm going to add a blank line to separate the two lines of code. This is what I mean. Enter in here, press Enter return key. There's a blank line between those two lines of code. That's the first thing I ask you to do. Just read the instructions carefully and then follow them. Add some comments to the code cell below. All right, let's add some comments. So it's plural, so I'm expecting 2 comments at a minimum. Well, here I would say this assigns the value of 2 to the variable x. That's a pretty obvious thing. And what does this do? This adds 3 to x. So there's 2 useful code comments that explain what's going on in the code. We create a markdown cell below this code cell and before the cyan border. Remember, we want to put all of the stuff for our activity between the cyan borders to explain the output of the code cell. So implicit in that instruction is that you actually run the code cell. So let's run the code cell. We see that the output is 5. So I will add a cell above this. I press the A key again. I went here and I pressed A to insert a cell. Now I want it to be a markdown cell. So I can either press escape so that it's not in the edit mode and press M for markdown, or just go up here and make sure that markdown is selected. And now I just want to explain the output of the code cell. Perhaps it's best, because there's 2 lines of code, to do this as a list. First, the value of 2 is assigned to the variable x. And I'm going to do x like that with tick marks. This is usually next to the tilde key, where if you press shift, like where you do strike through fonts, I'm using those tick marks. Look what happens. I'm just going to do control enter here. Look at the display of that. That displays it like it's code. Second, the value of 3 is added to x, and the output is then 5, because 2 plus 3 is 5. Well, equals 5. There you go. That's it. Something obvious and simple. You create a markdown cell for this. So again, this is for you to do. Did you do something like this? If you paused and watched it, if you haven't done it yet, you should go do it now, and you should write things as similar to what I did, but it doesn't have to be exactly the same. It's meant for you to do it in a way that's useful to you. Now, the interaction of all the code is broken down into cells, but in a single session of running a notebook, all of the cell executions form a single dialog with persistence of state between cells. What does that mean? Well, since we had x equals 2, notice again, x equals 2, notice how it's kind of highlighted this. It looks like code. It has that same kind of backdrop. That's because I used those tick marks around there when I wrote that markdown cell. So in that previous line where x is equal to 2, there's a new variable called x we can access in any other code cell. It has the value of 2 now. This value will persist if we perform another execution, unless you restart the kernel. So if you come up to kernel here and restart the kernel, that kind of wipes the slate clean. But if we don't do that and we run this code cell, this by itself will not produce an output. So I'll show this. If I comment out the print command and I just run this cell, there's no output. What this is doing is just performing 3 times x plus 1, and it's now assigning that to the variable y. So to see that output, I will print y. And you see, of course, it's equal to 7, because 3 times 2 plus 1 equals 7. 6 plus 1 is 7. Now, notice, this is executed. This is the 18th time I've run a code cell. Even if I've rerun certain code cells, a certain number of times, we're keeping track of how many times we run any code cell. Up here, this is 16. Now look what happens when I run this. That's 19. Even though this code cell, this code cell appears before this one. So that's a potential source of confusion. And I discussed this here, and you should read it carefully, but when you look at a notebook, you see a series of code cells in some order with your human eyes. You will look at it and say, okay, these code cells are in this order. However, you might start running things in different orders, especially as you're starting to debug and try to get things to work and fix things. And that can create some issues. So you want to keep track of the in and out tags, this number here, the in tag, and potentially this out tag here. I'm surprised it doesn't actually display an output there. I guess it's because of that print command. We're displaying something, we're not actually saying an output. If I just made that y instead, then there's an output tag. But I'll go ahead and change that. The main thing you want to keep track of is this tag, the in tag, because that's going to tell you at what point this was run relative to other code cells. And so if 22 is the largest number, you know this was the last thing run. And if you ever get a little confused and you need to run everything in the order you expect things to be run, then you can restart the kernel and run up to the selected cell you're in, or run all the cells. So these are options to have, and I discussed this more below. So then I give you this activity to understand this. Play with the order of code execution. Go back to the code cell where X is declared and copy and paste the contents into the code cell below. So again, you might want to pause the video now, read the instructions carefully, do this activity for yourself. It should only take a couple minutes, and then play the video. Or just watch me do this now and then do the activity. But you still have to do the activity because you're going to have to turn this in with all the activities completed for me to grade it. So I'm going to go back to where the code cell where X is declared, where it's made equal to 2, and I'm going to copy and paste the contents into this code cell below because it's between those cyan borders. So let me find it. Here it is. I now copied it. I use Control-C to copy it. I'm going to paste the contents with Control-V in. And now they're here. And I say split. That's the first step. I copy and pasted the contents in. Split the code cell into 2 separate code cells, each with a single line of code. So here, if I go to Edit, there's a split cell command. I select it, and it splits it wherever I put the cursor. And so again, here I'm undoing the code cell command. If I have the cursor right there, it's going to split the code cell right there. Right there. So if I had some other lines of code here, just, a bunch of, it doesn't matter. I'll just put a bunch of junk. Let's say that I put the cursor right here and I said, now split the cell. Notice it did it after that line where I had it. So undoing that, I don't want any of those things because it's just garbage. I will now split the code cell where I want it correctly. So each now has a single line of code. So the first 2 steps of the activity are now complete. I want to change X equals 2 to something else, execute it, and then execute the code cell above with Y equals 3 times X plus 1 again. So look what happens. Now if I make this 5, so that's something else, and I come back up here and I execute this, even though this code cell now appears before this one, look at the tag. This says 23, or we'll say whatever, some other number when you're running it because of however many times you've run code cells. But look at that number there. It should be larger than this number until you run this. And now you see this output's different. It's not 7 anymore. It's now 16. Well, 3 times 5 is 15 plus 1 is 16. So the output makes sense even though this appears, right, this code cell here appears before this code cell. I changed X equal to 5. This is really important to understand because if you were looking through this, if you handed somebody this notebook and you hadn't cleared the outputs and they were looking through it, they would say, well, geez, X is equal to 2. You add 3 to it, but you never saved it into anything. So X is still equal to 2. And then they would look at this and say, why? The question why? How is it that Y is equal to 16? Because 3 times 2 plus 1 is 7. It's not 16. Something's wrong. Something's weird. Well, if they looked at these tags, they'd say, oh, well, that's 24. That's 19. That's 23. So this was executed right before this one. But that's a lot to expect somebody to understand that that's what was going on. And I suggest even here, like, you could keep adding 1 to X by executing this over and over and over again and doing things. But you can do that on your own. You could just, if I run this a whole bunch of times, so I'll just do Control Enter, Control Enter, Control Enter, Control Enter. I've added 1 to X many times, and now if I come back and I execute this, now Y is 46, right? And that's impossible for somebody to figure out what happened. They're never going to be able to look at those values. So you should assume that the user, whoever you give the notebook to, we'll call that person the user, plans to execute the cells in the order they are given. So in order to make sure that the outputs are as you intend them to be, what you want to do is either go to run and say run all cells. There it is, run all cells. Or what I like to do is I like to restart the kernel and clear all outputs. And then I like to run all the cells after that. So that will clear everything from memory. So I expect you should try doing that. Play around with these ideas of restarting the kernel and clear all outputs, restart kernel and run. I want to make a very important point here. You should always do the following prior to any submission of a notebook. First, restart the kernel and run all cells. You should do that to make sure that everything runs and the outputs are exactly as you want them to appear. That everything's correct, because when you're making a lot of changes, maybe things are running because it's remembering something you did and it's not actually how the code is currently written. It was based on how code used to be written that you've now edited, but you haven't updated the order in which you've run things. So to make sure everything's working as it should, restart the kernel and run all cells. Once everything looks the way you want it to, then you will restart the kernel and clear all outputs. Once you do that, I'll show you here, I will restart the kernel and clear all outputs. I say restart, and now notice, all these are blank now. Nothing's been run, nothing's been executed. All those numbers are gone. You would then save your notebook, and then you will download the notebook. You will go to download, and then download that notebook, and then go to Canvas and upload that notebook. That's what you'll turn in. You'll turn into the relevant assignment. So the assignments will be designed so that you can upload files of type IPYNB, these Jupyter Notebook files. So those are the steps you should always follow prior to any submission. So then the rest of this notebook described is just involving activities that I will not show you how to do because they're for you. It's for me to learn a bit about you. So give me a brief biography of your relevant academic skills and background. So just use some lists and describe things here. So I give you the ability, you can leave that there and just, you can delete it. You can put your answer here. It's up to you. You don't have to have that. I'm prompting you to know to let you know where your answer goes. So, part A, tell me any programming classes you've taken in the semesters. If the answer is none, the answer is none. Just write none here. Perhaps it's none. Well, I have not taken any previous programming courses. You could write that. You don't have to have it highlighted. It's up to you. So just be honest, I guess, is all I'm asking. And then what do you want? I want to know why you're taking the class, in terms of not just that you have to, or it's to get your degree, but how you see this particular class being useful to you in your career or a life goal or an educational goal. Why is this an important class to you? And then let me know what your top academic or personal strengths are. Maybe you're a really organized person. Include at least 2 items in the list. I know there's got to be at least 2 good things about you. Let me know what grade you're hoping to earn in this class. A lot of people say A, but some people are more, hey, I'm happy to get a B. I'm just trying to learn material and the grade will take care of itself. That's fine. And then I let you know again about the expectations in the class, how much time you should expect to spend on it. And I want to know, how much time do you think you need to achieve the grade and this goal that you have for yourself about why you're taking this class? And then how do you plan on managing your time to do that? This is to help you start getting organized in your mind about managing the expectations that you have for yourself in this class and to get them aligned with each other. And then this is where this video will end. And I will have a very short video that will follow this. Will be the last one of this notebook that describes doing some tech style math typing in Markdown. That will be an important one to watch and to do that activity at the end. So thanks for listening, and I'll talk to you in the next video.